In section 7.7, our goal is to be able to determine and use the necessary skill required to find acute angle measures and/or side lengths of right triangles. Also, we want to be able to apply the use of solving right triangles to real-world problems. Let's begin with, what does it mean to solve a right triangle? It means to find everything, basically, that is a measurement that's missing. Find all the angle measures, find all the side lengths. We have all the skills. Now we just have to determine, when do we use them? Remember that the triangle sum theorem says that the angles of a triangle add up to 180 degrees. That's what it says. When do we use that? When we are given angles and need to find an angle measure. We're given angles, need to find an angle measure. So for example, just to draw a quick right triangle, let's say we're given two angle measures in this picture, 90 degrees and a 30 degrees. How do we find that missing angle measure? Well, all the angles add up to 180, so 90 plus 30 plus this blank one has to make 180. Well, if this is already 90, 180 minus 90 leaves us with 90, and 90 minus this guy leaves us with 60. 60. So our missing angle measure is 60 degrees. Pythagorean theorem, we know what that looks like. C squared equals A squared plus B squared, only for right triangles, but that's what we're talking about today, solving a right triangle. This is when we are given two sides and need to find a missing side. For example, here's a right triangle. We're given this side is 3 and this side is 4, and we don't know how much this side is right here. So we use our Pythagorean theorem, and then of course if we know our triples, we use that. Then we have SOHCAHTOA. This can be used for multiple things. One is, if we are given two sides and need to find an angle. What does that look like? I'll give you the same picture, a 3 and a 4, but this time what I'm missing is this angle right here, x degrees. Versus given one side and one angle and need to find a side. So what does that look like? Let's say that this side says 3 and this angle says 30 degrees, and what we're missing is this side. So there's different things that we use for the different things that we're given and the different things that we need. Let's take a look at some examples. Here are 3 examples that are very different. We need to know which skill to apply. Solve for the missing side or angle in each right triangle, round to the nearest tenth where necessary. So remember that nearest tenth means 1 decimal place. We have to know how to round and how the directions are given to us. So what are we given here? We're given two sides and we're looking for a side. Can you think about which skill that requires? Given two sides and need to find a side. If it's all about the sides, it's Pythagorean theorem. So for this one, we're using c squared equals a squared plus b squared. How do we know which is the c? Here's our right angle. Use it as an arrow, look across. There's our c. 15 squared equals x squared plus 9 squared. 225 equals x squared plus 81. Subtract 81 from both sides. 144 equals x squared, but I like to write the x first, and then take the square root. X equals 12. Number 2, here are two sides Just like this one, here are two sides, but here are two sides and we need an angle. That's different from when we need a side. We have to really look closely and see what are we given and what do we need to find. So looking back at our skills, given two sides but need to find a side is different from given two sides and need to find an angle. Remember that if it's a mix of sides and angles, it's SOHCAHTOA. Sides and angles, it's SOHCAHTOA. If it's only sides, sides, side, Pythagorean theorem. If it's only angles, 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 triangle sum theorem. If it's a mix of sides and angles, SOHCAHTOA. So in our second example, it's a mix of sides and angles. Sides and angles. So let's write down SOHCAHTOA. We'll make sure our calculator's in degree mode before we begin. Mode, check out degree mode. It is. So let's carry on. I need to find this angle. So from this angle, I will label opposite. And I always like to label across from the right angle before I do the other, hypotenuse. And then the remaining side is the side touching the angle in question, and that's called adjacent. Now I need to use two sides that I know to find the angle I don't know. I know the 3 and I know the 8. That involves opposite and adjacent. Opposite and adjacent is this one, tangent. Tangent, now I don't know that, so I can call it an x. Tangent of x equals opposite over adjacent, so 3 over 8. When I don't know the angle, that's when I need to get it to go to the other side by using the inverse. So I write x equals inverse tangent of 3 over 8. Now I can go to my calculator and I can do second tangent 3 divided by 8, enter. If I'm rounding to the nearest tenth, where necessary, I need to here. Here's the tenths place, 5 makes this go up, so 20.6. So let's write our answer. X is approximately 20.6 degrees. Remember, when it's an angle, you have to write degrees. Let's look at another one. I'm given a side and I'm given an angle, and I need a side. So if I'm given a side and an angle and I need a side, did you hear how that was a mix of sides and angles? And remember, whenever it's a mix of sides and angles, I need to use SOHCAHTOA. So I'm going to write SOHCAHTOA. Now let's figure out how to use that. Or remember how to use it. We already know. We just need a refresher sometimes. Here's the angle I'm given, so I'll look from that angle, and this is the side that's opposite. From the right angle, that is the side that's called hypotenuse, and the leftover side, or the side touching, is called adjacent. So I need to use what's given. That side is the opposite, and I need to find the hypotenuse. So if it's opposite and hypotenuse, it's sine. So I will write sine of 48 degrees equals opposite before hypotenuse, so 16 over x. Remember that when x is in the denominator, we divide. Denominator means divide. So do your interchanging, 16 over sine of 48 degrees, and now pull out your calculator. 16 divided by sine 48 equals, rounding to the nearest tenth, this is only a 3, so this stays a 5, 21.5. So x is approximately 21.5. I don't write degrees because x is a side, not an angle, like in the previous example. Pretty good? Sounds like you're getting it. Let's go ahead and apply it now.